Algebra might sound intimidating. Don't worry. It's like learning a new language. This language helps us solve problems. It uses letters and symbols to represent numbers and relationships. Think of it as a puzzle-solving toolkit. With algebra, you can tackle all sorts of challenges, from figuring out discounts at the store to understanding complex scientific principles. Algebra is everywhere. This essay will be your guide. We'll break down the basics of algebra. You'll see that it's not as scary as it seems. In fact, it's pretty cool. You actually start learning algebra early. Remember those missing number problems in elementary school? That was your first taste of algebraic thinking. In middle school, you probably encountered pre-algebra. This introduced you to variables and equations. Now, in high school, you'll dive deeper with Algebra 1. Don't worry if it seems challenging at first. It's a step-by-step process. Each concept builds upon the previous ones. Just stay curious and keep practicing. Arithmetic is about working with numbers. Algebra takes it a step further. It introduces letters called variables to represent unknown values. For example, instead of 5 plus 2 equals 7, you might see x plus 2 equals 7. Your goal is to find the value of x that makes the equation true. Algebra also uses symbols like equals, less than, and greater than. These symbols help us express relationships between numbers and variables. Let's explore some key concepts in algebra. Algebra is a branch of mathematics that uses symbols and letters to represent numbers and quantities in formulas and equations. It's a powerful tool that allows us to solve problems and understand relationships between different variables. Variables. These are letters like x, y, or z that represent unknown numbers. Think of them as placeholders. Variables allow us to write general formulas and solve problems where the exact numbers may not be known initially. For example, in the equation x plus 2 equals 5, x is a variable that we can solve for to find its value. Equations. These are mathematical statements that show two expressions are equal. For example, 2x plus 3 equals 7 is an equation. Equations are fundamental in algebra because they allow us to find the value of unknown variables. Solving equations involves isolating the variable on one side of the equation to determine its value. Inequalities. These statements use symbols like less than, greater than, less than or equal to, and greater than or equal to. For instance, x less than 5 means x can be any number less than 5. Inequalities are used to express a range of possible values for a variable rather than a single value. They're essential for understanding constraints and conditions in real-world problems. Graphing. Algebra uses graphs to visually represent equations and inequalities. This helps us see patterns and relationships. By plotting points on a graph, we can observe how changes in one variable affect another. Graphs are a powerful way to interpret data and make predictions based on trends. Functions. A function is like a machine that takes an input and produces a specific output. For every input, there's only one output. Functions are used to model relationships between variables in a wide range of fields, from physics to economics. Understanding functions is crucial for analyzing how different factors influence each other. Algebra is not just about solving abstract problems. It has real-world applications, from calculating interest rates in finance to determining the trajectory of a rocket in physics. Algebra is a versatile tool that helps us make sense of the world around us. By mastering the core ideas in algebra, you can develop critical thinking skills and solve complex problems in various domains. Section 5. Your first steps, topics in Algebra 1. This section will guide you through the foundational concepts that are essential for mastering Algebra 1. Whether you're new to algebra or just need a refresher, these topics will set you on the right path. In Algebra 1, you'll cover a variety of topics that build upon each other. These topics are designed to help you develop a strong understanding of algebraic principles and problem-solving techniques. Linear equations. These equations create straight lines when graphed. You'll learn how to solve for variables, understand slope and intercepts, and apply these concepts to real-world problems. Quadratic equations. These equations involve variables raised to the power of 2 squared. Their graphs are curved lines called parabolas. You'll explore how to factorize quadratics, use the quadratic formula, and understand the significance of their roots. Rational equations. These equations involve fractions with variables in the numerator or denominator. You'll learn techniques to simplify these equations and solve them, which is crucial for higher level math. Radicals. You'll learn about square roots, cube roots, and other radicals. Understanding radicals is important for solving equations that involve roots and for simplifying expressions. Polynomials. These are expressions with multiple terms, like 2x squared plus 3x minus 5. You'll study how to add, subtract, multiply, and divide polynomials, as well as how to factor them, systems of equations. This involves solving multiple equations with multiple variables simultaneously. You'll learn methods such as substitution and elimination to find solutions that satisfy all equations in the system. Mastering this topic is key for advanced algebra and calculus. Section 6. Mastering Algebra Study Tips for Success. Algebra can be a challenging subject, but with the right strategies, you can master it. Whether you're just starting out or looking to improve your skills, these tips will guide you towards success. Here are some tips to help you excel in algebra. Practice regularly. Consistency is crucial when it comes to mastering algebra. Set aside dedicated time each day to work on algebra problems. This will help reinforce your understanding and make complex concepts more manageable over time. Just like playing an instrument or a sport, consistent practice is key. Think of algebra as a skill that improves with regular practice. The more you engage with the material, the more familiar it will become, and the easier it will be to solve problems. Work through problems in your textbook and seek extra practice online or through workbooks. Utilize all available resources. Textbooks often provide a variety of problems that can help you understand different aspects of algebra. Online resources and workbooks can offer additional practice and explanations. Don't be afraid to ask for help. Everyone struggles sometimes. It's important to recognize when you need assistance. Asking questions is a vital part of the learning process. It can help clarify doubts and solidify your understanding of difficult concepts. Don't hesitate to ask your teacher, classmates, or a tutor for help when you need it. Show your work. When you seek help, make sure to show your work. This allows others to see where you might be going wrong and provide specific guidance to help you improve. Write out each step of your problem-solving process. This practice not only helps you keep track of your thought process, but also makes it easier to identify and correct mistakes. It's a good habit that can lead to better accuracy and understanding. This helps you catch errors and understand the logic behind each step. Understand the concepts. Instead of just memorizing formulas and procedures, focus on understanding the underlying concepts. This deeper comprehension will make it easier to apply your knowledge to different types of problems. Focus on understanding the why behind the rules, not just memorizing them. When you understand the reasoning behind algebraic rules and procedures, you can approach problems with greater confidence and flexibility. This conceptual understanding is key to long-term success in algebra. Section 7. Algebra in action, real-world applications. Algebra might seem abstract, but it has tons of real-world uses. Science. Scientists use algebra to model physical phenomena, analyze data, and make predictions. Engineering engineers use algebraic equations to design bridges, buildings, and other structures. Computer science algebra is the backbone of programming languages and algorithms. Finance algebra helps with budgeting, investing, and calculating interest rates. Everyday life, you use algebra without even realizing it. Calculating discounts, converting measurements, and figuring out travel times all involve algebraic thinking. Section 8. Beyond Algebra 1, a glimpse into the future. Algebra 1 is just the beginning of your mathematical journey. After mastering the basics, you can explore geometry, study shapes, sizes, and spatial relationships. Algebra 2. Delve deeper into advanced algebraic concepts, trigonometry, explore triangles and their properties. Calculus. Study rates of change and accumulation. These subjects open doors to exciting careers in STEM fields and beyond. Section 9. Conclusion. Embracing the power of algebra. Learning algebra is like gaining a superpower. It equips you with problem-solving skills that extend far beyond the classroom. Embrace the challenge. Don't be afraid to make mistakes. With dedication and perseverance, you can unlock the power of algebra and open up a world of possibilities.